Welcome back, my AP Calc champions. In this problem, we're going to be talking about this function f. So the function f is defined on the closed interval -2 to 8 and satisfies f of 2 is equal to 1. The graph of f prime, the derivative of f, consists of two line segments and a semicircle as shown in the figure. So up here. First problem asks, does f have a relative minimum, a relative maximum, or neither at x equals 6? Give a reason for your answer. Okay, so I think with these problems, it's really important to notice that this is the graph of f prime. You don't want to start assuming that this is the graph of f just because the first sentence talks about f. So you want to be really careful reading this problem. This is the graph of f prime. Okay, so the point that we're trying to evaluate is at x equals 6. So if you had thought that this was, the graph of f, you might have thought this was a relative minimum. What does a minimum look like? It looks like where the slope goes from negative to positive. What does a relative maximum look like? It would be the opposite. So where a slope goes from positive to negative. And then if neither one of these conditions is true, then that would mean that it is neither a relative minimum nor a relative maximum. So let's see what happens with f prime of x. So as we're approaching our x equals 6, so at x equals 5, it looks like the value of f prime is above the x-axis. So our f prime is positive as we're approaching that point. And then once we look to the right of x equals 6, to like x equals 7, for example, we see that f prime is still positive. So it's positive on both sides. So it doesn't look like it matches either one of these conditions where the first derivative goes from negative to positive or positive to negative. I would say that f has neither a relative max nor a relative min at x equals 6 because f prime of x doesn't change signs. Moving on to the next problem, we're being asked, on what open intervals, if any, is the graph of f concave down? Give a reason for your answer. Concave down. How can we determine when the graph of f is concave down? That would be when the second derivative is going to be less than 0. Then it's gonna look like this, concave down. So we have the graph of f prime right now, so we can look at the slope of the graph of f prime to determine the second derivative value, right? Remember that just like if you were looking at, say, for example, the graph of f, to get the value of f prime at a certain point, you're going to be looking at the slope of f. So what this means is what we're looking for is when the slope of f prime of x is negative. Okay, so let's take a look at our graph. So it looks like we actually start off with a negative slope. So from -2 to 0, it looks like our graph would be concave down because the slope of our f prime is negative. Okay, so I would say that would be from -2 to 0. Okay, and then so from 0, it looks like we're actually increasing our slope. So I would say that from 0 to 4, we would not say that the graph of f is concave down. So here it's negative. I would say up here it's positive, so that won't count. And then when we look at 4 to 6, it looks like once again our slope is negative. So we can add that to our open intervals, so from 4 to 6. And then once we're looking from 6 to 8, it looks like we're once again increasing. So this would be positive. We would not include that in our open intervals, right? So what we're just looking for is a negative slope. That only happens for between -2 and 0 and 4 and 6. So I would say that this is our answer for problem B. Moving on to the next problem, this one says, find the value of the limit as x approaches 2 of this expression here, or show that it does not exist. Justify your answer. Okay, so let's go ahead and write this out. So the limit as x approaches 2 of 6 times f of x minus 3x over x squared minus 5x plus 6. So let's go ahead and let's just try to plug in 2 and see what that gives us. So we get the limit as x approaches to 6 times f of 2 minus 3 times 2 over 2 squared minus 5 times 2 plus 6. So f of 2, we're being told in the problem, is 1. So we can go ahead and substitute that out. Then we have minus 3 times 2, which is 6. So it looks like up top we have 6 times 1 minus 6. So this is actually just going to be 0. Okay. Let's look at the bottom. We have 2 squared, 4, minus 5 times 2, that's going to be 10. So we have 4 minus 10 plus 6. So actually it looks like the bottom is also 0. Uh-oh. So 0 over 0 is an indeterminate form, right? That's not great for us. But this doesn't necessarily mean that the limit does not exist. Why do I know that? So we actually use our friend L'Hopital's rule. This says that if we get into one of these indeterminate forms, so 0 over 0 or infinity over infinity, what we can do is we can take the derivative of the numerator and the denominator and then try to solve for the limit like that. The conditions for this that need to be true are that both the numerator and the denominator are differentiable on both sides of a. So for us, it looks like we're looking at, so f of x is differentiable on that entire interval minus 2 to 8, right? We have the f prime of x defined for it. So I would say that this whole numerator is differentiable, right? We're just multiplying f of x by 6 and then subtracting 3x. 3x is always going to be differentiable. And then down at the bottom, we just have a quadratic function. So that is also going to be differentiable around x equals 2. So I would say we can go ahead and try to use L'Hopital's rule for this limit. So we are going to take the derivative of both the numerator and the denominator. So it's going to be 6 times f prime of x minus 3 over, drop the 2 down, just simple power rule, 2x minus 5, and then the 6 goes away because it's just a constant. Okay, so now we have it in a slightly different form. Let's go ahead and plug in our 2 and let's see if this is going to get us out of this indeterminate form. So we get limit as x approaches 2, 6 times f prime of 2 minus 3 over 2 times 2 minus 5. Okay, let's see. We have the graph of f prime right above. So let's go ahead and see what f prime of 2 is. It looks like it's just 0. So let's go ahead and plug that in for f prime of 2. So we're going to get up top minus 3 over 4 minus 5, so minus 3 over minus 1. So we're going to get that the limit as x approaches 2 of this expression is 3. So if you find yourself with this indeterminate form, do not say that it does not exist, okay? You might be able to use L'Hopital's rule, and in this case, we actually were able to use L'Hopital's rule. Let's move on to the next problem. This one says, find the absolute minimum value of f on the closed interval minus 2, 8. Justify your answer. When do absolute minimums happen? They happen when the graph goes from a negative slope to a positive slope. Okay, or it might happen at our endpoints. So in this case, we're going to be using something called the candidates test to evaluate each of the candidates that we have available. So let's see. So we know that 2 of our candidates are going to be our endpoints. So minus 2 and 8, those could be potential absolute minimums. So let's go ahead and add those to our table. So we have x and then we have f of x. So minus 2 is 1, and then 8 is also 1. Okay. Next, what we need to look for is where f prime of x goes from negative to positive. So where does f prime of x go from negative to positive? It looks like at the point 2, we go from a negative f prime of x to a positive f prime of x. So I would say that would be another candidate here. And then let's keep going. It doesn't look like there's anywhere else in our graph where we started from a negative value and we swapped over to a positive value. So I would say that these are our 3 candidates, minus 2, 2, and 8. So we're trying to find the minimum value of f. And right now, we are told that f of 2 is equal to 1. So we can go ahead and put that in our table. So now we're looking to see if the values at f of minus 2 or f of 8 are going to be less than 1. And compare them all to find the actual absolute minimum value. Okay, so how are we going to find f of -2 and f of 8? Well, remember that the area under the curve of f prime should help us figure out what f is. Okay, so using f of 2 as our starting point, we can use the area under the curve help us figure out f of -2. So we can set this up like f of -2 is equal to f of 2, and we have to go backwards to figure out f of -2. So what we're going to do is we're going to subtract the area under the curve from -2 to 2 of f prime of x dx. Another way you can think of this is, maybe if this setup isn't really working for you, is we can add this integral to the other side. So if our starting point was f of -2, we would add the area under the curve to make it to f of 2. Okay, so what I just did there is I just subtracted this integral from f of 2. Okay, so hopefully that makes sense. So we have our f of 2. Our f of 2 is 1. So now to solve for f of -2, all we need to do is find the area under the curve of f prime of x from -2 to 2. So luckily for us, it's made up of these little shapes. Yippee! So our first shape is this little triangle. Remember that the area of a triangle is 1/2 base times height. So our base is 1 and our height is 2. So 1/2 times 1 times 2. This is going to end up being just 1. And then let's see what other shapes we have. We have another little triangle. You might notice that it is the exact same area as our other triangle, but since it's under the x-axis, it's negative. So it'd be 1/2 times 1 times -2. So this is going to be -1. So these areas effectively just cancel each other out. And then we still want to get to our 2. So there's one more triangle we need to add to our calculations. So once again, 1/2 base times height. Looks like this base and height is going to be 2. So 1/2 times 2 times 2 times -2. So this is going to be 2. To add up all of these, so to get the area under the curve from -2 to 2, we're going to add them all up. So 1 minus 1 plus -1 plus -2. So these cancel out. We're going to get 1 minus -2. So this is going to be 3. So we have solved for our f of -2, so that's going to be 3. So between our f of -2 and our f of 2, it looks like our f of 2 is maybe going to be the more promising candidate, just because 1 is less than 3, but we still have to evaluate f of 8. Let's go ahead and do that. So f of 8, we're going to apply that same concept we did to find f of -2, but this time we're going to be adding, because we're moving positively from f of 2. So starting at f of 2, and we want to end at f of 8, we have more shapes we need to find the area of. Let's see, this first one is a little triangle. So the triangle, 1/2 base times height, so 1/2 times 2 times 2, so that's going to be just 2. Then we have a little more complicated of a shape. So you'll notice here we have a semicircle. So if you drew like a rectangle around this semicircle, we want to find the difference between the semicircle and that box. Okay, the way that we can find that is we can take the area of the box. So that's 1, 2, 3, 4, base times height. So 4 times 2, so 8. And then we can take the area of the semicircle. So that's going to be pi r squared divided by 2, because it's a semicircle. If it had been the whole circle, we wouldn't have to divide by 2, but since it's a semicircle, we do. So our radius is going to be 2. 1, 2, okay? So pi times 2 squared over 2. So we can just get rid of one of those 2's. So the area of the semicircle is 2 pi. So then, remember, we only wanted the area under the curve. So that's going to be the difference between our rectangle and our semicircle. So that's going to be, this area here is going to be 8 minus 2 pi. So I forgot to set up my equation, but that's okay. So f of 8 is going to be equal to f of 2 plus the area from 2 to 8 of f prime of x dx. So we know that f of 2 is 1, so 1 plus, and then we found the area is going to be the combination of these areas here. So that's going to be 2 plus is going to be the combination of the yellow and the purple. 8 minus 2 pi, so 1 plus 10 minus 2 pi, so it's going to be 11 minus 2 pi. So f of 8 is going to be 11 minus 2 pi, so that is also greater than f of 2. So it looks like our absolute minimum value is going to be 1. So I went ahead and I solved the area under the curve from 2 to 8 of f prime of x. You might actually notice I didn't really need to do that. The reason why is we started with f of 2, which is 1, and then we added the area under the curve from 2 to 8. You might notice that the area under the curve here is going to be all positive, right? It's all above the x-axis. So regardless of what the area under the curve from 2 to 8 was, we weren't going to get a number less than 1, which was already the absolute minimum value that we had found at f of 2. So if you were like running short of time, maybe you could have noticed this and you didn't have to find your area. I just did it for the sake of completeness. But yeah, so the absolute minimum value by the candidates test would be 1 for this problem. Hopefully that helps you out with this AP Calculus problem. If you have any questions, feel free to leave them down below and I'll get back to you. And I hope you have a great rest of your day.